We start with a vector space V that carries some representation U. And then, let's say, take this bunch of vectors here, emu1 to emu d mu, that transform in the unitary irrep gamma mu. Now we know that we can expand arbitrary psi's in our vector space in such basis vectors. So I've written this here, and the coefficients here are just complex numbers. And now we want to apply our representation u. So what happens? Calculate u of g, apply to psi. We only have to look here. These transform in irrep gamma mu, so we just copy the rest. Sum over mu, sum over, let's say, alpha and beta from 1 to d mu, c mu beta, e mu alpha, and let's say gamma mu of g alpha beta. So this is what it means that these transform in this irrep here. Okay, now we have these matrix elements showing up here, and now let's exploit the orthogonality of matrix elements. So use orthogonality of matrix elements. That is, we multiply with some other representation matrix elements and sum over all group elements. Let's write this down. So we need, for normalization purposes, we need dimension of an irrep d mu prime, order of the group, and the sum over all group elements. And now we write here gamma mu prime of g, alpha prime, beta prime. It's a complex conjugate if we do this with the unitary representations. And then here's the u of g and the psi, which we already had above. So that's the green part, which we already had. And now let's just copy the rest from up here. So this is equal to this. And we just have to insert the blue part somewhere. Let's do this just here at the end. No, doesn't fit. So the blue part goes here. Okay. So what can we do with this equation? Well, now we have character orthogonality. So this thing here is just a bunch of deltas. So there is a delta mu mu prime, a delta alpha alpha prime, a delta beta beta prime. That is, we can perform all these sums here using these deltas. So we get c mu prime beta prime, e mu prime alpha prime. Okay, now we have this is equal to this, and let's fix the mu prime, let's fix the beta prime, and let's fix the psi. And let's vary the alpha prime. So only this one here is what we vary, the others are fixed. So this means that if this number is 0, then this expression is always 0, because we fix this. this was actually a mu prime, by the way. There's no mu left. Okay, so if this is 0, then it's always 0. This term on the right hand side here. If this one is not 0, then we are, by varying alpha prime, we construct an irreducible invariant subspace. So this means we can take these guys here and use them in order to construct irreducible invariant subspaces, in order to project. So it makes sense to investigate these operators here, which I circled in yellow, a bit more closely.